we have an array and want to iterate through it, the easiest way is to do as follows. Sometimes it's popular to use pointers instead and rewrite the code to this. And that's just a waste of time because the compiler will do it for you much faster. Okay, if you use optimization, that is. If optimization is not permitted, then this may be an option. But what we can see here is that something interesting happens. Namely that this end pointer actually points to the first byte after this array. And here we compare with the dangerously looking pointer, but it's not. Defined in this C standard is that an array must have a valid byte just after it. That means not every array has an extra byte, but there must be okay, let's put it like this. If we have this memory layout and we have instructions and we have data, then and we have well, let's say we have just one big array here. That's the only data we have in the program, and then the compiler must assure that there is one more byte. And if we had instead not one but two arrays, then there will be one extra byte for all of this data segment, and the same for stack, etc. So we can use this pointer and compare it with this end. And this is, as I mentioned, this is done automatically by compilers, and in the Optimizing Compilers course you will learn how this is done. Actually, if you took the algorithms, data structures and complexity course recently, you will have you remember that you saw Tarjan's algorithm for strongly connected components that is used to perform this optimization in a very nice way. Okay, so let's look at this example instead. What can happen here? Well, what we do is to go down and is this valid? So what we do here is to iterate until P has come to an address which is before this array. But that address is not guaranteed to exist. It's highly likely this code will work, but if somebody uses a tool to detect memory errors, that tool can complain. Okay, and the reason is that, I mean, when this has been decremented, it will point to one element before. So in this one does not exist, but P will point to it, and that may be non-existing in memory. So, well, it doesn't exist, but it may be an invalid address, so we shouldn't do that. A compiler can do it if it knows that this address is valid. Okay, of course. Another thing with expressions is something called a sequence point. And a sequence point is, for example, a semicolon. That's the most common sequence point. And a sequence point, the most important thing about sequence points is that we are only allowed to modify a variable once between two sequence points. So this is bad. This is bad, and this looks like I don't know what, but something perhaps, and it's also bad. Okay, and a variable must not be read after a modification before the next sequence point. So say the code, and this code is wrong, but it may be valid. I mean, we shouldn't write code like this, but it may actually be valid when we run the program, but it's really bad style and dangerous. So if we start, I mean, here we have an add, obviously, and which operand is evaluated first, the left or the right? That is decided by the compiler when it generates code. It does not have to be documented, and this, as you remember, is called unspecified behavior. So let's say it evaluates this first. Then it starts with reading, and it has read this, and then it modifies A. Then it's fine. But if it starts with modifying A and then reads A, then it has violated this. May not read after a modification before the next sequence point, which is what happens if we take and evaluate the left operand first. So code like this is just very bad and should never be written. Another thing which is sometimes useful is a comma expression. It's most commonly used as in the first expression in a for statement. So say we want to initialize two variables, then we can use a comma expression, and what happens is that each one is evaluated in time, I mean after each other, obviously, and the value of this, well, the value is ignored anyway, but in the for this place, but in general the value is the last expression. Okay, so here we have not three operands but two operands, and this is a comma expression, and the first value and the second value, and the value of this comma is the last one, so it's 2, so 2 will be printed.